All right, so this afternoon I was looking over some material and I looked at a news story that came up on the Wall Street Journal early weekend that Trump's job approval rating had ticked up. And so I went through and I decided where this poll would come from. I used 538.com to give me some of this information because they have all the details. And it looks at the NBC News and Wall Street Journal did a poll with a sample size, their sample size here of 900 people, and they had a job approval rating of 46%. So that I know in our sample here in February, they had a job approval rating of 46%. And I know I had a sample size in February of 900. And of course, they're saying it increased. So I want to scroll back and take a look. Well, what had happened before? So I scroll all the way down and take a look. Oh, January. I found it earlier. Oh, was that too far? No, that's okay. I hadn't quite got there yet. Here we go. January 2023, NBC News, Wall Street Journal. Sample size of 900. Oh, good. So I've got my P hat for January. My sample size of January. Sample size was 900. And we found a job approval of 0.43. The reason I found this interesting, it may not be visible anymore. If we look through the poll, we're not going to be able to find it there. It's 46%. But if I look, let's see if we can click into it and find the information here. They told us what the margin of error was. So let's click the poll, see if we can get the margin of error. So 2020 race, you want to talk about all of it. This is great. I just want to know what the poll was. How'd the poll come in? Okay, voters, who was going to vote for him? Not too worried about that. Let's see if we can find this poll numbers here. A little tough. Okay, 46%. Oh, margin of error, 3.27%. So both of these have about the same margin of error, about 3%. Read this, and they're talking about his rating ticked upwards. I thought that was kind of odd. Because if I look, it was 46 or it was 43%. The 3% margin of error. So it was somewhere from 0.4 to about 0.46. But now they're saying it's 0.46 plus or minus 3%. And I was like, wait, how can you say it increased when they have all this overlap in what it could have been? And when we call our confidence intervals, we use that margin of error, what we're saying is that it could have been anywhere in this range. And it could have been anywhere in the entire interval. We don't know necessarily where. Oh, I'm sitting here writing on my paper. I'm showing on mine. That we don't know where it is. It's anywhere in this first interval. It's somewhere in this interval. We don't know where. It could be in this area where there's all this overlap. We just don't know. So I was like, how could they refuse that? And it looked like maybe this headline is a little misleading. And what I want to know is there a difference in the proportion of people who are approving the job rating? Well, this is a hypothesis test. I want to see, is there a difference between two proportions? So I can do that. I just need a little bit more information. I need to know how many people this represents. It's 0.46 out of 900. How many is that? And I can do a hypothesis test. Now, my null hypothesis is that the proportion of people in January who supported is the exact same as the proportion of people in February. That's equal. It hasn't changed. Alternatively, I'm testing whether or not the February is greater than the January poll numbers, because this is what we're saying. And we're using these samples to make estimates about the population. And in words, job approval is unchanged, or job approval rating is unchanged. Alternatively, job approval rating has increased. That's what the Wall Street Journal's headline said. So I actually have some of my information here in my X's, but that's easy enough to come up with. I had 900 people polled, and 43% said they approved. Now let's just multiply by 10, make that 900. So 387, that's what we had in January. And now it's 46%, 414. And I can actually run this as a hypothesis test. I should check my conditions. It should be a random sample. And I have my January and my February. Yeah, professional poll. So it's reasonable. So I'd have a random sample because a professional poll would be random. You need independence because this is how we're building. We're building our independence. I also need to make sure 10 success or 10 failure. Well, I have 414 success this time. I have 387. I got those backwards. 387 and 414 success. And let's see, 900 minus 387. So 513 fail. And 900 minus 414. Of course, 900 minus 414. We have 486 fail. Success and fail greater than 10. So we met it for both conditions. And we stayed far below 10% of the population. Okay, 10%, not too many, of population. So 10 times 900 equals 9,000. 10 times 900 equals 9,000. 9,000 is less than 300 million. This is approximately how many people are in the U.S. So we're well below that. So we have independence. We have a large enough sample. It will be approximately normal. Now, last we need is, are these groups independent from each other? Are the groups independent? Okay, professional poll ensures don't ask the same people twice. At least often in most cases. Reasonable, they're independent. So it's a reasonable assumption. Now, in this case, now I can actually test my hypothesis. And for that, I'm going to use a calculator. So I use a calculator, I'm going to make a mistake. Now, a few things. If I didn't use a calculator, I was going to need to get my pooled P because I haven't rejected the null hypothesis. So I'd have to say, well, 414 plus 387 out of 900 plus 900 to go to pooled P hat. And all these are values I have to come up with in order to actually run this manually. So if I do that, then divide by 1800, I get 0.45. That would let me then find my Z by doing the difference, 0.46 minus 0.43, minus the null hypothesis value of 0, divided by our standard deviation. Well, now it's going to be 0.445 times 0.555 all over 900, plus, do it again, because it's two samples. If I do this, I'll get a Z-score. Let's see, 0.03, that's my numerator, divided by the square root of our first fraction, 0.445 times 0.555, divided by 900. Add our second one, which is the exact same value. Get out of our square root. So we have a Z-score of 1.28. I'm looking for the probability, Z, and let's see, we need, well, I want to say the new ranking is higher, so the probability will be higher. .8, which means I'm looking for this region. So it's normal, CDF, lower is 1.28, upper 1E99, mean is 0, the z-score, and standard deviation is 1. And if I do this, I'll get our probability. Second vars, normal CDF, 1.28, all the way up to just do 5 nines. Put this in. We have a probability of 0.100. That's fairly large p-value, is our p-value. Well, that's a large p-value. My alpha, well, at worst, it's 0.1. I'm not less than my alpha. I might be equal to it, but I'm not below my alpha. I would fail to reject the null hypothesis. I do not have evidence his rating actually went up. Now, that's if I do it manually. Let's see how it takes to do if I do it by the calculator. So again, stat test, and I want a 2 proportion z-test. So now we go into it, 2 prop z test, and I tell it x. Let's see, we're going to do x1 to be January, n1 to be January, x2 to be February. So x for January, we had 387. N for January, 900. X for February, 414. N for February, 900. And we'll see, what am I looking for? Well, I'm looking, this is where all my previous work helps, for my hypotheses that the probability, or I'm sorry, the proportion in February is greater than the proportion in January. But if I look, I have January then February. Down here I'm comparing. So this would be they're not equal. January is less than February, so that's the one I want. The last one would be January is more than February. I want this middle one. January is less than February. Or P1 is less than P2. And if I run this, I can calculate. It gives me all my values. My z is negative 1.28 because I ran it. But p-value is still 0.10. It gives my p1 and my p2. I can find all my values. Now, the other thing I can do, though, make sure it's right. 2 prop z test. 387 is January. Oh, I didn't want January less than February. I was testing as January. Let's see, 387. Yeah, it's January less than February. That was right. So I was right. I can also draw it. Now, the way I ran this a little backwards, so my curve is backwards compared to what I want to test. I'd have to flip this in order for it to make sense. My z would still be 1.28, and it tells me that is my p-value of 0.1002. Again, I would reject the null hypothesis. So after I ran this, I was kind of like, yeah, how could the Wall Street Journal say that there was definitely an uptick? Well, let's go back over to those 538 polls. Because according to my hypothesis testing, no, I would fail to reject the null hypothesis. As far as I can tell, there's no difference between them.